For the rest of Chapter 7, we are going to learn how to factor polynomials. We've already learned how to take out a GCF, and today we are going to learn how to factor quadratic trinomials. So a quadratic trinomial means that the highest degree is 2, and trinomial means there are 3 terms. And so today specifically, we are going to learn how to factor trinomials that have a leading coefficient of 1, which means a is equal to 1. So let's work backwards and then we'll work forwards, because working backwards is something that you are already familiar with. Suppose I wanted to multiply x plus 4 times x plus 7. I could do that. I could do the distributive property, I could make a table, or I could FOIL. X times x is x squared. And we're going to use that fact when it comes to factoring. X times x is x squared, so if you start with x squared, you can work your way back. X times 7 is 7x. X times 4 is 4x. 4 times 7 is 28. So you get x squared plus, when you combine like terms, 11x plus 28. Now we want to be able to start there and work our way backwards. Are there any patterns that we can notice about 11 or about 28, specifically in regards to how they relate to 4 and 7? Well, 4 plus 7 is equal to 11, and 4 times 7 is equal to 28. So when it comes to factoring, I'm going to be working backwards. I'm going to be looking for two numbers that multiply to be my last term, which is C, and multiply to be my last term, and add to be my middle term, which is B. And then, like we said, x times x is x squared. So what does that look like? Well, if I gave you the trinomial x squared plus 9x plus 20. I'm looking for two numbers that add up to be 9 and multiply to be 20. Because when I set this up, what multiplies to be x squared is x and x. And so I need two numbers that multiply to be 20 and add up to be 9. I usually start with my factors of 20 because as far as whole numbers go, we're a little more limited usually with multiplication. So 1 and 20, 2 and 10, you might not need to show this work to recognize that the two numbers that multiply to be 20 and add up to be 9 are 4 and 5, which means x plus 4 and x plus 5. And in case you're wondering, I could have put plus 5 first and then plus 4. It means the same thing. I only need one answer though, but either one would be correct. There's no importance as to which number goes first. So let me give you x squared plus 7x plus 6. How would you factor that? Feel free to pause the video and take some time to think. X squared factors into x and x. Two numbers that multiply to be 6 are 1 and 6 or 2 and 3. And the two numbers that multiply to be 6 and add up to be 7 are 1 and 6. Or you could have put the 6 first and then the 1 second. So in general, when everything's positive, it's a little more straightforward just because we're only dealing with positive numbers. Now let me get my book set up here. Let's say that there's some negatives involved. So if I'm asking you to factor x squared minus 8x plus 12. The idea behind what we're doing is not going to change. I'm still looking for two numbers that add up to be b, but in this case, b is negative 8. So I have to find two numbers that add up to be negative 8 and at the same time multiply to be positive 12. So as far as numbers that multiply to be 12, we've got 1 and 12, we've got 2 and 6, we've got 3 and 4. We know that two positive numbers multiply to be positive. But what else multiplies to be a positive number? Two negatives. So we've got negative 1 and negative 12. Negative 2 and negative 6, negative 3 and negative 4. So the only two numbers that multiply to be positive 12 that also add up to be negative 8 are negative 2 and negative 6. X squared is still going to split up to be x and x. So I've got x minus 2 and x minus 6. And if I wanted to check my work, I could multiply. I get x squared minus 6x minus 2x plus 12. Negative 6, negative 2 gets you right back where you started. So just to verify, technically we won't get any of these wrong because I could always multiply it out. I could check the multiplication, at least in my head, and make sure that when I multiply everything out, I'm not connecting these in the right order. I think I did F, whatever. They multiply out. They work. You get the original problem. So factoring is inverse of multiplying polynomials, or it's backwards, it's opposite. So if I can multiply, I can learn to factor because I know what I'm trying to get to. I'm just working backwards. So let's try a practice problem. Let me see here. What about w squared minus 4w plus 3? And then I'm going to give you x squared minus 14x plus 24. So feel free to pause the video and see if you could factor these. So I set up w and w, two numbers that multiply to be positive 3 and add up to be negative 4 are negative 3 and negative 1, or they could be in the other order. I would be careful on IXL. They're going to be picky about the variable that you use. So if they start off in W's, make sure that you stay in W's. It's not always X. And then two numbers that multiply to be 24 and add up to be negative 14 are negative 12 and negative 2. So if B is negative, here I'll circle in red. If B is negative and C is positive, then I'm looking at two negative numbers. If everything's positive, I'm looking at two positive numbers. So the next line would be, what if C is negative? So what if I give you x squared plus 4x minus 21? I'm still asking you to factor. The only way that I can use whole x's to get x squared is x and x. And so I'm going to split that up. And now I have to think about what I'm looking for here. I'm looking for two numbers that add up to be negative 4 and multiply to be negative 21. So take a second to think about how something's going to multiply to be negative 21. Well, it could be that it's a negative 3 and a positive 7. Or it could be a positive 3 and a negative 7. Or it could be a 1 and a negative 21, or a negative 1 and a positive 21. And I think that's all the whole number factors of negative 21, but one is positive and one is negative no matter what. So I'm looking very specifically for two numbers that not only multiply to be negative 21, but add up to be positive 4. And the only two numbers that multiply to be negative 21 that add up to be a positive 4 is negative 3 and positive 7. The 3 has to be negative and the 7 has to be positive, because if I'm going to multiply and check my work, x times 7 is plus 7x, negative 3 times x is minus 3x. I don't want those to be flipped and get a negative 4, and then negative 3 times 7 is negative 21. So I do get back where I started, x squared plus 4x minus 21. But as long as the 3 is negative and the 7 is positive, it could go in either order. I could put x plus 7 and then x minus 3. Those are both okay. But I can't put a plus 3 and a minus 7 because those do not add up to be 4. They add up to be negative 4. So let's say that the original problem was x squared minus 4x minus 21. That's a different story, and you have two different answers. Then it would be a positive 3 and a negative 7. And that's what we're going to do next. if we've got v squared minus v minus 42. I'm looking for two numbers that multiply to be negative 42. What do they have to add up to be? What is technically the coefficient in front of this v? Whether it's written there or not, there is a 1. So I'm looking for two numbers that multiply to equal negative 42. I guess I should put multiply. And add, or here, let me use my red pen because I'm on a roll, keeping up with my colors. Add to equal negative 1. So I would start by coming up with numbers that multiply to be negative 42. 3 and 14 maybe is the first thing that comes to mind. 2 and 21 might be the first thing that comes to mind. Or 6 and 7, more likely than not, were the two numbers that came to mind. I just have to be careful which one's positive, which one's negative. When I add these two together, I want to get a negative 1 according to this problem. So the only two numbers that multiply to be negative 42 and add up to be negative 1 are 6 and negative 7. And so for that reason, the only way that I'm going to get v squared is v and v, and I can put plus 6 and then minus 7. So only feel the need to do this problem one time, but if you had said negative 7 first, you're not wrong. Again, as long as the 7 is negative and the 6 is positive. So I will put a couple more practice problems on here to finish up, and then you'll go over to the IXLs. The IXLs that you are expected to do, I'll make sure to post on RenWeb. Make sure you get access to those, because right now I don't know what those are going to be off the top of my head, but I could give you x squared plus 2x minus 15, and then I'll give you n squared minus 12n plus 35. And then I'll give you y squared plus 13y minus 30. And then I'll give you, these are hard to make up. I think I'll do a squared plus. Start working on the other three while I come up with what this fourth problem is going to be. Because I have to make sure that it's actually solvable. Let's do plus 6a plus 8. I changed my mind. Let's do a squared plus 6a plus 9. So feel free to pause the video because I'm going to do all the answers. So the two numbers that multiply to be negative 15 and add up to be positive 2 are a positive 5 and a negative 3. So you might have put the minus 3 first, but the 3 has to be negative. Two numbers that multiply to be 35 and add up to be negative 12, well, n and n, multiply to be positive 35 means they're both negative. So minus 7, minus 5. And then when it comes to y and y, multiply to be negative 30 and add up to be 13. Ooh, this is actually a tricky question. Let's do this on the next screen so I have more room to write. So what was it? Plus 13y minus 30. Because I don't know about you, but right off the top of my head, I think of 30 as 3 and 10. But check it out. It has to equal a negative 30. So which one of these are you going to make negative? Only one of them is allowed to be negative. And if you make one of them negative, they're not going to add up to be 13. So I have to go back to the wheelhouse. I have to decide what multiplies to be negative 30. What else multiplies to be negative 30? Well, 6 and 5, but those don't add up to be 13 regardless of which one you make negative. Don't ever forget about 1 as an option, but that's not the case in this case. Or you're screaming at your screen by now, 2 and 15, Miss Barrett. Yes, 2 and 15. So 2 and negative 15, or negative 2 and positive 15. And the only two numbers that multiply to be negative 30, and add up to be positive 13 is a negative 2 and a positive 13. So y minus 2 and y plus 15. Or you could put the 15 first and then the minus 2. Either way, doesn't matter. As long as the 2 is negative and the 15 is positive. And then last, we have A and A. Two numbers that multiply to be 9 that add up to be 6 are 3 and 3. So there's nothing wrong with leaving this as your answer, but something that I can recognize is that if the quantity is written twice, that's the same thing as writing it squared. So if we were solving, negative 3 would be the solution twice, and so there's repeated solution, and we aren't going to get into those details right now, but you could rewrite it either way. Your teacher would accept it in either way. I don't know what the computer would accept, but you have to find out. So those are the basic problems of this section. So I'm going to end this video. I may make another one that has some of the more complicated problems, like the word problems or multiple variables, things of that nature. But thank you for watching. Go Sykes!